All right, so today we'll be talking about constructing scatter plots and then drawing some information off of them and a little bit more details about the scatter plot themselves. Now, what I've done, just for the interest of time, I've actually constructed the scatter plot already. So if you're looking at your paper, this area is probably blank, but what I've done is I've taken the data here about Jared's basketball team and I've just placed it on this graph. Now, what Jared has done is that his team stood at different distances from the hoop, and for 30 seconds they shot, and this kept track of all the shots that they made. Some students made 10 shots in 30 seconds, some students made only 2 shots in 30 seconds, but the distance varied, so that could have an impact on how many shots that they made. So we're going to describe the type of association seen in the scatter plot. So when I'm looking at this, I'm seeing that there's a trend this way, downward. So I would say there's a negative association. Now, I would say this is also a linear description of it because it's staying in a line. And then I don't know if this would be a strong or a weak. I'm going to go ahead and say this is a strong correlation. Only because if you think about the actual implication of what this is saying that the farther away you are, the fewer shots that you make. And that's a pretty strong implication. So I'm going to go ahead and put that the relationship is strong there. So are there any points that don't fit the overall trend of the data? And I would say, yeah, there is. That's this guy right here. I wonder why he is by himself. We're going to talk about him specifically. So the point that we're looking at is 15 and 2. It's actually Jared's data. So let's keep going. It says, describe any unique observations about the shape of the graph. Well, I noticed that I got some groupings here and some groupings here, and there's this big gap in the middle that supposedly, if you're at 20 feet, then you wouldn't be able to get any shots, or 25 feet and no one got any shots. It's a little bit an odd separation there. We're going to talk about that too. So if I made some statements about the scatter plot, so as the distance from the hoop increases, so as I'm farther away, the number of baskets decrease. And I think that statement would be true. We just talked about that, how the farther you are away, the more difficult it is to make a shot. So the likelihood of you making it goes down, so your shots go down. So as the distance from the hoop decreases, so as I get closer, the number of baskets increases. Well, I think that would be correct also, because the closer you are, the easier it is, and the more shots you'll make. So what is actually going on this scatter plot? Well, there's two things that are happening in this scatter plot. The first thing we're going to point out is an outlier. So an outlier is a point that does not fit the overall pattern. He lies outside the pattern. That's why they call him an outlier. Now, the second thing that we're seeing is clustering. Now, clustering is whenever there is a distinct or separate group of points. So, for example, there's clustering here and clustering here. So I'm going to go ahead and label that. That's a cluster. That's a cluster. And then I forgot to label our outlier. All right. So you're going to hear it being called clustering. You're going to hear it also being called grouping. So what does that actually mean in the long run? What information does that tell us? Well, let's take a look at some examples over here again. So first, I'm going to take a look at our graph. This one, again, I pre-populated. So if you're looking at your blank paper, I've put the points on. You can go ahead and pause the video and populate it as you see fit. But this is basically just telling us that the number of elementary schools that they have in the area and the population, or the number of people that live in that area, and these is in the thousands, right? So it says, describe any association or conclusions you can make from the graph. So the first thing that I can go ahead and conclude that this is a positive association because it's moving in the same direction. It seems that the number of people that I have increases the number of schools that I have, and they both increase in the same direction. And then I would say that this is a pretty strong association, and it still makes a line, so I would say that it's linear again. So does the graph appear to have any outliers? And I would say it does right here, this point right here. So I'm going to go ahead and draw that. That is our outlier. And it is at the point 20 and 18. All right, so do I see any clustering? And this time I would say no. There's no real gaps. And I think the reason there's no gaps here is because whenever we make schools and we keep track of population, there are planning committees that go into this. And so there's a distinct decision made whenever they make the amount of schools, and depending on the amount of population that you have. So someone decided that this is going to happen. It's not random data like this, like the shooting of a basketball. It either could or could not go in. The likelihood will be increased or decreased depending on the skill level of the player, but it could be considered random. So why is this outlier out here? So there's several problems, or maybe not problems, maybe several different issues that would cause this outlier to exist. Because they're saying that if there's only 20,000 people, they still have 18 schools. Well, there's several things you can say about that. It could be that this area is very, very wide. There's like a big amount of area. And so, but it only holds 20,000 people in it. And the distance that they would have to travel to go to all the schools would be too much. So they decided to make more than one school in certain areas, and then it just accumulated to be 18. Another reason may be that this is taking into account maybe charter schools or private schools or alternate schools. And that's why there are more than one type of school in that area. So there's 100 type of reasons that you can think of why outliers, but this is why outliers are important, because they cause us to think of different scenarios that could happen, and then we're able to use those scenarios to either prevent those outliers from happening again, or to learn from those outliers to where we can make our trends approach that. So let's take a look at this next one. So again, I've populated the scatter plot for us, and then we're going to describe it. I see a line like that, so I'm going to say that this is a negative association. I'm going to say that it's linear because it makes a line, and I'm going to still say that it is strong because these dots are pretty close together. Now, does this appear to have any outliers? And I'm going to say no, because it looks like the amount of money that is spent over a certain amount of days and the amount of money that's in the account seem to be pretty consistent. I don't see any one student spending more money than they're supposed to. Now, what would cause an outlier? Well, an outlier might occur if, let's say, for one day, maybe early on in the month, a student has a birthday and they decide to get some snacks and they spend more money. So on the 6th day, they've dropped their account. That could be the reason there's an outlier. Another reason there might be an outlier, maybe on the high end, is that they're refilling their account. So maybe in day 10 or day 12, they see that they're approaching a lower amount. So the parents decide to refill it all on once. And so it kind of balloons the amount of money they have in the middle of the month. That could be a reason an outlier is there. So does this demonstrate any kind of clustering? Well, I think it does. So I have a group here, nothing, and then a group here. So I do see some clustering. Now, why could that happen? Now, it could be that these first few days were the number of days in a week. So this could be Monday, Tuesday, Wednesday, Thursday, and then maybe they had a 3-day weekend. They were off Friday, Saturday, Sunday, and then maybe Christmas or Thanksgiving break happened and no one used any money. And then when they came back, they decided to, on the 14th day, everyone used all their money and brought it right back down, buying snacks and stuff like that to where it was supposed to be. So there are clusterings here and here. So that gives you different ways to describe a scatter plot and different kind of thoughts to have about what could or could not happen in a scatter plot. And that helps you make predictions on future data. So hopefully this gives you a better understanding of scatter plots. But if not, as always, you can come see me in tutoring.